Good morning, students. How are you all? Hope you are all fine and safe at home. Today we can start with a new chapter and a new topic. So before mentioning the chapter name and the topic, I'll show you two things and you should tell me whether you are familiar with these two things. Here I have a soap and a lemon with me. Are you familiar with these two things? Of course, yes, right. This is soap and this is lemon. And we can make a lime juice using this lemon, right? And we can make soap solution using this soap. Is there any similarities between these two? Is there any similarities between these two? Is there any differences between these two? Okay, now we can do another activity and you will get familiar with our chapter name and the topic from that activity. So shall we do the activity? So here is our activity. Here I have taken vinegar in a beaker, soap solution in a beaker and lemon juice in another beaker. And I have red and blue litmus papers with me. I am going to put red litmus paper in all three solutions and blue litmus paper in all three solutions. Now we can observe the color change obtained in red and blue litmus papers. First, I am taking red litmus paper and I am going to dip it in vinegar, soap solution and lemon juice. Observe the color change. I am going to put this red litmus paper into vinegar. Is there any color change? Is there any color change? No. Now we can dip red litmus paper in soap solution. What do you observe? What do you observe? The red litmus paper turns blue while dipped it in soap solution. Now we can dip red litmus paper in lemon juice. What do you observe? Is there any color change? Is there any color change in red litmus paper dipped in lemon juice? No color change. Now we can take blue litmus paper and we can dip blue litmus paper in all these solutions. First, I am going to dip it in vinegar. What do you observe? The blue litmus paper turns red while dipped it in vinegar. Now we can dip blue litmus paper in soap solution. What do you observe? Is there any color change in blue litmus paper dipped in soap solution? No color change. Now I am going to dip blue litmus paper in lemon juice. What do you observe? The blue litmus paper turns red while dipped it in lemon juice. Is the activity clear for you? Have you observed the activity? Yes, the activity was about dipping red and blue litmus papers in soap solution, vinegar and lemon juice. And we have seen that the blue litmus turns red while dipped it in vinegar and lemon juice, and the red litmus turns blue while dipped it in soap solution. From this, what inference can you arrive at? What is the difference between this vinegar, lemon juice and soap solution? Yes, we can observe the differences between all these solutions, the vinegar, lemon juice and soap solution in today's class. So, shall we start the class? In the beginning of the class, you have seen that vinegar and lemon juice turns blue litmus red, right? Vinegar and lemon juice turns blue litmus into red, which means they are of what nature? Yes, acidic nature. To study in detail about the characteristics of acids, we can have a video. So I'll show you a video now. The video is about the reaction between the highly reactive metal zinc acid hydrochloric acid. Reaction between the highly reactive metal zinc and the acid hydrochloric acid. So observe the video and we can arrive at a characteristic of acid. So observe the video.
In this reaction of hydrochloric acid with zinc, highly reactive metal zinc was added to a test tube containing hydrochloric acid. As you can see, some bubbles are formed there. The bubbles formed shows the presence of some gases. In order to check the presence of the gas formed, a burning matchstick was shown at the mouth of the test tube. What happens? Observe the video.
Have you observed the video? Yes, the video was about the reaction between zinc and hydrochloric acid. What do you observe there? Is it a vigorous reaction or a slow reaction? Yes, it was a vigorous reaction, right? What substance is formed there as a result of the reaction between zinc and HCl? What do you observe there? Now I'll show you a picture card and based on that picture card you can arrive at a conclusion about the characteristic of acid. So observe the picture card.
The picture card represents the reaction of zinc granules with dilute HCl and the gas evolved was tested using a burning candle. Dilute HCl was taken in a test tube and zinc granules was added. As you can see, the gas evolved is passed to a soap water and the presence of gas evolved is tested using a burning candle. What do you observe?
Have you observed the picture card? Yes, the picture card explains about the reaction between zinc and dilute HCl and we have tested the gas evolved using a matchstick. And here the gas evolved is tested using a burning candle. What do you observe? What do you observe? Yes, it put off, right? So, the reaction between the highly reactive metal zinc and the acid dilute HCl will form what gas? Yes, hydrogen gas. Now we can see the equation for this reaction. Zinc react with HCl to form zinc chloride plus a gas is evolved there, right? Which gas is evolved there? Zinc plus HCl. Zinc, HCl gives ZnCl2 and what is remaining there? Hydrogen. So the gas evolved is hydrogen. As a reaction between the highly reactive metal zinc and the acid dilute HCl, a gas is evolved there and the gas is hydrogen gas. And this is very common for all the other acids too. When acids reactive with highly reactive metal, when acids react with highly reactive metals like zinc, hydrogen gas is formed. Now, let me ask you a question. Will the same hydrogen gas be formed when acids react with the carbonates? Will the same hydrogen gas be formed? Let's see. For that, I'll show you a video. So watch the video carefully.
In this reaction of calcium carbonate with hydrochloric acid, a test tube was taken and into this test tube calcium carbonate was added. And then dilute hydrochloric acid was added to the calcium carbonate taken in the test tube. What do you observe? Observe the changes carefully. As you can see, when dilute HCl was added to calcium carbonate taken in a test tube, some gases was evolved there. To check the presence of the gas evolved there, the gas evolved was passed on to a lime water taken in another test tube. As you observe, the lime water turns milky.
Have you observed the video? Yes, the video was about the reaction between dilute hydrochloric acid and calcium carbonate. And some gases evolved there, right? Some gas was evolved there. What gas was evolved there? Yes, we have tested the presence of gas using lime water, right? We have passed the lime water. We have passed the gas evolved into a lime water and observed that the lime water turns milky. Now, I'll show you a picture card of this experiment. So, observe the picture card.
The picture card represents the reaction of calcium carbonate with dilute hydrochloric acid. Calcium carbonate taken in a test tube and added dilute HCl. Some gas was evolved there. To check the presence of gas, the gas evolved is passed on to a lime water taken in another test tube. As you can see, the lime water turns milky and it shows the presence of carbon dioxide gas.
Have you observed the picture card? Yes, it shows the reaction between calcium carbonate and dilute HCl. Here it is. The reaction between calcium carbonate and HCl and a gas is evolved there. To check which gas was evolved there, it is passed on to a lime water. As a result, the lime water turns milky and it shows that the gas evolved is a carbon dioxide. Is it clear? When calcium carbonate reacted with dilute HCl, which gas is evolved there? Yes, carbon dioxide gas was evolved there. So, acids react with the carbonates to form carbon dioxide gas. Acids react with the carbonates to form carbon dioxide gas. Is it clear for you? So, we have discussed about two experiments and from these two experiments we have concluded that acids react with highly reactive metals like zinc to form hydrogen gas and acids react with carbonates to form carbon dioxide gas. And in the beginning I have shown you an activity. Do you remember the activity? The red and blue litmus papers dipped in vinegar, lemon juice and soap solution. And we have observed that while the blue litmus paper dipped in vinegar and lemon juice, they have turned red, and when the red litmus paper dipped in soap solution, it turned blue. So, from all this activity, we can conclude certain characteristics of acids. Next, we are going to conclude our activities by showing a chart. So, observe the chart carefully. Here I have a number of cards with me, and in this card I have written some of the features of acids and alkalis. You should tell me or you should identify the characteristics that will be suitable for acids. So I will read each. First one, soapy to touch. How does it feel when we touch vinegar or lemon juice using our fingers? Is it soapy to touch? No. What about soap solution? Is it soapy to touch? Yes. So, this feature is for soap solution or an alkali. Now, I'll show you another card. Yes. Have sour taste. This will be suitable for which type of solutions? Acid solution or basic solutions? Yes, it will be suitable for acidic solution. So, it's a characteristic of acid. So, we can check, we can stick this on the chart. So, acids have sour taste. Next, I'll show you another card. Yes, what is it? Turns red litmus into blue. Which solution turned red litmus blue? Soap solution, right? So it is suitable for basic solutions, right? Now, I'll show you another card. Yes, have alkaline taste. From the feature itself, it is clear that this is for alkaline solutions, right? Now, react with carbonates to form carbon dioxide gas. We have seen the video of reaction between carbon dioxide and acids, right? And which gas is evolved there? Carbon dioxide gas. So, react with carbonates to form carbon dioxide gas and it will be suitable for acids. So, we can stick it here. Yes. React with the carbonates to form carbon dioxide. Now, turns blue litmus red. This is suitable for which type of solution? Yes, acidic solutions like vinegar and lemon juice, right? So, acid turns blue litmus red. So, we can stick it here. Here it is. Now, liberate hydrogen on reaction with highly reactive metals like zinc. From the first video, it was clear that the acids like dilute HCl react with highly reactive metals like zinc to form hydrogen gas. So, this is a characteristic suitable for acid. So, I'll explain it once again. We have discussed about the characteristics of acids in today's class. As we all know, acids like vinegar, lemon juice, etc. have sour taste. So, it's a characteristic suitable for acid and react with the carbonates to form carbon dioxide. We have seen the video of reaction between calcium carbonate and dilute HCl and it was clear that on reaction with carbonates, acids form carbon dioxide gas. Next, turns blue litmus red. From the activity we have done at the beginning of the class by dipping red litmus paper and blue litmus paper in 3 solutions of vinegar, soap solution and lemon juice, it was clear that vinegar and lemon juice, it turns blue litmus red and they are acids. Now, liberate hydrogen on a reaction with a highly reactive metal. From the first video, it was clear that dilute HCl react with a highly reactive metal like zinc to form hydrogen gas or to liberate hydrogen gas. So, have you got an idea about the difference between soap and lemon? Yes, in lemon, what is present? Acid is present and in soap, what is present? An alkali or base is present. So, this was the difference between the solutions vinegar, lemon juice and what? Soap solution. So, this is all about the characteristics of acids. So, that's all for today. Catch you all in the next class. Stay home, stay safe. Thank you.